When you look at this question and you see that a force is applied to an object, mass is given, and there's some information on forces, straight away you should know it's a question on dynamic. So the formula of F equals to ma should be used. The acceleration is what the question wants. The mass has already been given. So what is the resultant force? You can see that a force of 0.5 newtons is acting on it. Is there any force that's acting in the opposite direction? Nope, because the question says it is frictionless. So that means the only force that's acting on it is this one. So since there's only one force acting on it, 0.5 is the resultant force. So F equals to ma. So 0.5 is 0.1 times a. You can work out the acceleration to be 5. And again, dynamics is a chapter that's very closely related to kinematics. So you would expect that sometimes the question may be linked to questions from kinematics. Determine the speed at the end of 3 seconds. Well, the acceleration, since the force of 0.5 newtons is applied for 3 seconds, that means you will have a constant acceleration of 5 meters per second squared for 3 seconds. So acceleration is 5. Final speed, I don't know. Initial is 0. How do I know it's 0? It says here it is at rest. So time is 3. So final speed is 15. So what is the motion of the plastic sheet after 3 seconds? Well, after 3 seconds, you do not apply any force anymore, because the question says that you only apply this force for 3 seconds and then you remove. So after 3 seconds, there's no more this force. There is no friction. So basically, there's no force acting on it. So it will just continue with this with this velocity of 15 meters per second. So our answer is constant velocity of 15 meters per second, right? Because by then there will be no more resultant force. So therefore acceleration equals to 0. Therefore it will always travel with constant velocity. And the next one, you're supposed to draw free body diagram. The easiest one to draw, of course, is the weight. Remember, you have to draw from the middle of the object vertically downwards. So that is the weight. You always label. Normal contact force. Normal means 90 degrees. So make sure it's 90 degrees. And you draw a force that is towards the object. Okay, so that is normal contact force. Again, labeling is important. If you want, you can draw a 90 degrees. And now this plastic sheet, if it's placed on a surface that has no friction, it would have slide down. But since the plastic sheet remains at rest, that means there must be a friction that is actually preventing it from sliding down. So the tendency is for it to slide down. So now the friction would be upwards. You can draw it here, or actually you can draw it here also if you want. So this is friction. And you're done. One force, one mark, and you have scored